System configuration to improve reliability. The first thing we think about to improve reliability is the doubling of components. Hardware like the CPU and peripheral devices is doubled. Let us look at a typical system configuration example. 1. Dual system. Two computers do identical processing. The processing results are referenced at fixed intervals in this system. When one computer goes down, the other continues processing. In this system, there is no loss caused by a failure. Even during normal times, the error ratio of processing results is low. Because of this, the reliability of this system is very high. However, economically this is a very expensive system. The processing ratio in relation to cost is very low. Two. Duplex system. This system is configured with two computers. One computer handles online processing. The other computer is a spare machine that handles batch processing. When the online machine goes down, it is replaced with the spare machine and online processing continues. From the standpoint of reliability, the replacement time is a loss. It is the most generally used online system. The system that is configured with a single communication control unit computer is called a simplex system. When this system fails, it is down until it is restored. Because of this, it cannot be said to have good reliability. However, from the cost standpoint, it is relatively inexpensive. 3. Hot standby system. In a duplex system, interrupting the job being executed on the standby system, starting up the program to go online and switching over communications lines and devices require a small amount of time. With the hot standby system, the communications line and all of the devices are shared. This means that the standby system is always running the online programs. Because of this, it can be switched over instantly. System failure monitoring is done, and when failure is detected, it is automatically switched by the resident control program. There is almost no switchover loss. Because of this, it can be said that its reliability is slightly higher than the duplex system. 4. Multiprocessor system. Processing is divided using multiple CPUs. The main memory/auxiliary storage files are shared in the system. If one CPU goes down, that CPU can be cut off and processing can continue. Processing efficiency and reliability are high. It is a system with flexibility and expandability. 5. Load sharing system. Multiple CPUs are connected. The overall system processing performance is improved by load sharing. The load is mutually shared between CPUs in accordance with load conditions. Because of this, usually different processes are done in each CPUs almost as if they were completely different systems. When trouble occurs in a CPU, the remaining CPU handles the processing, and therefore the processing performance goes down. However, The system is not stopped. 6. Tandem system. Multiple CPUs are connected in series. The system is structured so that load distribution is carried out between them. Tandem means horses in a row. Each of the CPUs lined up in series is an analogy of a horse. Seven. Clustering system. Clustering system is a group of linked computers, working together closely so that they virtually form a high-reliable single computer. It is often used for client-server system. The purpose of clustering system is to avoid the single point of failure when one computer fails or to share the computing tasks depending on system workload. 8. Multiplexing of peripheral devices. A. Multiplexing of input-output devices, auxiliary storage, etc. The objectives are enhanced performance and ensuring substitute functions in cases of failure. Multiplexing of magnetic disk devices, magnetic tape devices, and printers is done. B. Multiplexing of access paths. Access paths are multiplexed. This is so that access can be gotten through other paths when a part of the access paths, the circuit from the CPU to each input-output device, to the CPU, such as the CPU, input-output channel, input-output control unit, or input-output device fails. C. Multiplexing of the communications control unit, etc. Multiplexing the data communication equipment, DC. Modem or DSU, communications control unit, CCU, communication control processor, CCP, and so on. D. Multiplexing of communication lines. Doubling communication lines or establishing backup lines, for example, using a public communication line to back up a dedicated line, using a wireless line to back up a cable line,